This is a C. Jason podcast, and my name is Arthur Lee. On behalf of the authors, I want to thank C. Jason for the opportunity to share our team's work on this podcast. In this project, we looked at blood untargeted metabolomic profiling to identify metabolite signals related to neurocognition in children with CKD. This work was possible thanks to the extensive collaboration within the NIDDK CKD Biomarkers Consortium. One of the overarching goals of this consortium is using metabolomic data to gain new pathomechanistic understanding in how various CKD comorbidities develop, and if these are potential therapeutic targets. Neurocognitive dysfunction in children with CKD is phenotypically unique compared to adults. What drives neurocognitive dysfunction in children may not be the same in adults. For our team and myself as a pediatric nephrologist, this really emphasizes the need for dedicated study in children with CKD. This study was really strengthened by the opportunity to perform replication analyses in 2 samples, which is a rarity in pediatric CKD omics type studies. We looked at the CKID and NIC studies. CKID is an ongoing multi-center prospective cohort of children with CKD, and the participants had repeated longitudinal metabolomic profiling and neurocognitive phenotyping. NIC is a smaller single-center cross-sectional study that included matched healthy controls. We used the CKID baseline as our discovery sample and performed the replication analyses in the CKID follow-up and NIC samples. With this approach, we were able to identify both confirmatory and novel metabolite signals related to neurocognitive function in children with CKD. A notable confirmatory finding was that gut microbiome-derived substances, such as phenylacetylglutamine, associated with worse neurocognitive assessments. A novel finding was that gamma-glutamyl amino acids, a downstream product in glutathione redox homeostasis, associated with better neurocognitive assessments. We think this study is an early study in identifying how comorbidities develop in children with CKD. In the future, we hope to be able to leverage additional genomic and proteomic data to help us characterize the pathomechanisms and identify therapeutic targets. Thank you.
This podcast is copyrighted by the American Society of Nephrology. All rights reserved. All content in this podcast is for informational purposes only and is not intended to be medical advice. This podcast should not be used in a medical emergency or for the diagnosis or treatment of any medical condition. Please consult your doctor or other qualified healthcare professional if you have any questions about any medical condition or before taking any drug, changing your diet, or commencing or discontinuing any course of treatment. Thank you for listening to this podcast from the American Society of Nephrology.